Hi everyone! In this video we're going to solve compound inequalities that have the word "and" in between them. Here's our first example. I'd like to note that this entire expression, those two inequalities and the word "and" in between them, make one compound inequality. So we're going to be doing the way it looks. We're going to be solving two inequalities at the same time. Now this word "and" plays an important role, and I'll explain it in a few moments. Let's start solving this compound inequality step by step. In step number 1, we need to solve each inequality separately, so we're going to focus on one at a time. Let's do the first one. To solve this inequality, we just have to get x by itself. First, I'm going to add 5 to each side. This will give me 2x greater than 4. And then I divide by 2 on the left and on the right. So I'll get x is greater than 2. Okay, so the first inequality is solved. Now I'm going to solve the second one. Here I'll have to subtract 2 on the left and on the right. This will give me 2x is less than or equal to 14. And then I'll divide by 2 on the left and on the right. So x is less than or equal to 7. That's step 1. After you solved each inequality separately, then you want to graph both solutions, but on the same number line. The first solution is x is greater than 2. I'll place 2 on the number line, and because the inequality symbol is greater than, I'll place an open circle at 2. That means that 2 itself is not included in the solution. X is greater than 2 represents all values that are greater or larger than 2. They're located to the right of 2 on the number line. That's where I'm highlighting. The second solution is x is less than or equal to 7. First I'm going to place 7 on the number line. At 7 I put a closed circle because the inequality symbol is less than or equal to. It means that 7 itself is included in the interval. The x values that are less than or equal to 7 are the numbers that are smaller than 7. It means they're positioned to the left of 7 on the number line. And again, I made sure to highlight all the way to the end. I use different colors to better see each graph solution, and using different colors is very helpful in the process of solving compound inequalities, because this is what we need to do in the next step. In step 3, we need to find the intersection of the solution sets. The intersection of sets is another set that contains values that are in both of the original sets. And if it's a little confusing, then graph will really help us to understand what it is. What I highlighted in blue represent values in the solution of the first inequality. What I highlighted in red represents solutions of the second inequality. What values are in both solutions? Well, they will be in the interval that has both colors on the graph, red and blue. In other words, interval from 2 to 7. Since it has two colors, it means that values from both solutions are in that interval. And this interval will be a solution to the entire compound inequality. This is how I like to think about it and remember the way to solve a compound inequality when it has the word "and". "And" means the intersection of the solution sets of those two inequalities, but the easier word is the overlap. So basically on the graph, I am looking for the overlap of the highlighted intervals. Once I located it, I just need to describe it using interval notation. That will be step 4. Write answer using interval notation. As we can see, the overlapping interval starts at 2, ends at 7. At 2, I'm going to place parentheses because I have an open circle there. And right next to 7, I'm going to put a bracket because I have the closed circle at 7. So this interval represents the solution to the given compound inequality. Let's do one more example. It's another compound inequality with the word "and". To get x by itself in the first inequality, I'm going to subtract 4 from each side. From there, I'll get negative 3x is greater than negative 9. And then I'll divide by negative 3 on the left and on the right. Here I have to remember that every time when I divide by a negative number, the inequality symbol changes its direction. So I'll get x is less than positive 3. To get x by itself in the second inequality, I'll start by subtracting 6 from each side. I'll get 5x is less than or equal to negative 10. And I'm dividing by 5 on the left and on the right. So I'll have x is less than or equal to -2. In the second step, we're going to graph both solutions on the same number line. The solution to the first inequality is x is less than 3. I mark 3 on the number line and place an open circle because the inequality symbol is less than. And the solution represents all values of x that are less or smaller than 3. They're located to the left of 3, so that's the portion of the number line that I'm going to highlight. I make sure to highlight all the way to the end of the number line that's drawn here. The second solution is x is less than or equal to -2. I'm going to place -2 on the number line. And at -2, we're going to have closed circles since the corresponding inequality symbol is less than or equal to, meaning that -2 is included in the solution set. And this inequality symbol represents all values that are smaller than -2. So again, I have to highlight to the left of -2. I'll use a different color for that. Once we graphed both solutions on the same number line, we need to find the intersection of the solution sets. That's because we're solving the compound inequality with the word and. And here's the reminder of how we think about it. Intersection is the same as the overlap of the highlighted segments. In other words, I have to find the portion of the number line where I have both colors, blue and red. Well, that's this part. This is the interval that includes values of x from both solutions. And that's why it's called the intersection of the solution sets. Let's describe this interval using the interval notation. We always have to read the number line from left to right. We have to say where the interval starts on the left and where it ends on the right. The left arrow of the number line indicates that values are decreasing in that direction and approach -infinity. So on the left we have -infinity, and for future examples I'll make a note that on the right we have +infinity. But going back to our interval to describe it, on the left we write -infinity, so it's from -infinity, and then it goes all the way to -2. That's where the overlap stops. We always put parentheses right next to infinities, and right next to -2 I'm going to use the bracket because of the closed circle. The bracket indicates that -2 is part of the set. And that's going to be the solution to the given compound inequality. And here's one more example of the compound inequality with the word and. Let's solve each inequality separately. So for the first one, to get x by itself, I'll add 4 to each side. And then I'll divide by 3 on the left and on the right. I'll get x is greater than 2. In the second inequality, to get x by itself, I'll add 2 to each side. And then to get rid of the negative sign in front of x, I'll divide by -1 on the left and on the right. Again, I have to be careful here and remember to switch the inequality symbol because I am dividing by a negative number. So I'll get x is less than or equal to -4. I solved each inequality, so now I'm going to graph both solutions on the same number line. The first one is x is greater than 2. I place an open circle at 2 and highlight to the right. And the second one is x is less than or equal to -4. I place -4 on the number line with a closed circle. Values that are less than -4 are positioned to the left of -4. Once I graph both solutions on the same number line, I need to find the intersection of the solution sets. Remember, on the graph, it's the same as the overlap. In other words, portion of the number line where I have two colors at the same time. Do I have an interval like that? No. Here on the left, I only have the red color, well, it represents solutions to the second inequality. Right in between -4 and 2, I don't have any color. And then to the right, I have only blue because that represents solution to the first inequality. So there is no overlap. In other words, these two solution sets do not intersect. This means that the given compound inequality has no solution. So no solution is going to be the answer to this question. One of the notations that we can use for such answer, no solution, is the symbol. So it's like crossed out circle. It indicates an empty set. So these are the steps for solving a compound inequality with the word and we looked at different cases that you can get when you solve this kind of compound inequality.